All right, let's go through. This is going to be our last video for this year, starting on number 9, and then we'll kind of work through the end of this review. So, graphing a quadratic inequality. Again, this one we related to just graphing a regular graph, and then we looked at this piece right here to decide whether it was dashed or solid, right? If it was a greater than or a less than, then we knew that it was a dashed line when we draw our function. And if it's a greater than or equal to or a less than or equal to, that includes those solutions, so then we do a solid line. And looking at this one, we know that it's going to be a parabola, right? We've got this like x squared plus 4x minus 2. So we just need to find the vertex and graph this. Now you can use Desmos if you'd like to. It graphs actually inequalities really nicely. You just plug that whole thing in. So remember, we used that a little bit in class. It was desmos.com, and you can graph different functions. Or again, we can find the vertex using x equals negative b over 2a, so either of those. So I'm going to go ahead and use x equals negative b over 2a. When I do that, remember my b value here is 4, so I want to do the opposite of positive 4, which is negative 4. And then my a value is like a negative 1 there, so we're going to do 2 times the negative 1. That will give me negative 4 over negative 2. And if we divide a negative 4 by a negative 2, we end up with a positive 2. So when I'm writing my vertex, right, I know that the x value is going to be 2. Then to find the y value, again, like the last video, we plug the x in to the original function. So we're going to say y, what would it be equal to, right, if we put a 2 in because of this 2 every time we see an x. So 4 times 2 minus 2. So simplifying that, oops, I forgot my squared. 2 squared is 4, and there's that negative out front. So negative 4 plus 4 times 2, which is 8, and then that minus 2 on the end. So if we simplify all of that together, negative 4 plus 8 minus 2, we end up with 2. So we're going to have 2 comma 2. Again, that's going to be the vertex, right? So over here, I'm going to graph 2, 2, and then this one's upside down because of that negative in the front. And again, we can use Desmos to plot this, or your calculator, or we just have to remember parabolas go up by perfect squares. And then we're going to go ahead, and this one, right, is just a greater than. There's no or equal to, so we're going to make this a dashed line. Alright, then the last thing we do is we graph, right, above or below the function. So this one is greater than, which means above the function. So remember, if it looks like this, we're going to graph above the function, or shade, sorry. If it was opening this direction, above the function would mean right here. All those points that stay always above the function. So in this case, we're going to graph or shade above the graph of the function. So the solutions would be all of this part right here. And again, if you're using Desmos, it will help you actually with that shading. All right, let's talk about solving quadratics. So on this page, you're going to be practicing just factoring or quadratic formula, or just the square roots to solve. So the first section asks you to practice solve by factoring. So remember, to solve a quadratic, the first thing we always do is we set it equal to 0. So to do that, and I'm going to work through number 11, number 10, very similar. I'm going to move the 8, right? I'm going to add 8, and I'm going to add 8. And the reason I'm writing it under the 38 is because that's its like term, so we'll combine those. This will leave us with a squared minus a, and then we have subtract 30 there when we combine that, and then nothing left on the other side. Once it's equal to 0, we look for a greatest common factor. Now notice here, there's nothing that divides out of 1 and negative 30 that's bigger than 1. So nothing to divide there, so then we just backwards FOIL what we practiced on the last assignment. So things that multiply to negative 30, because we know that the a will just split up as a and a. So if we look at factors of negative 30, they need to have a difference of 1, right? This is like there's a 1 right there. So 30 and 29, oh, not 30 and 29, 30 and 1. If we subtract those, we get 29, so that doesn't work. 2 and 15. If you subtract those, you get 13, so that doesn't work. 3 and 10 are factors. 3 and 10, if we subtract those, we get 7. Then we move to 5 and 6. Yeah, they have a difference of 1, right? If we make the 6 negative, that would give us that -1 that we're looking for. So we want to use a +5 and a -6. Once that's factored, we've done the hard part. Now we just say, well, what would make this piece equal to 0? Well, what plus 5 is 0? That would be a -5. And then we look at this piece and we say what -6 would be 0? And that would be a +6. So our solutions there would be a -5 and a +6. Okay. Solve by taking the square roots, right? So notice that this one up here had an a squared term, it had an a term, and then a constant term. If you look at this one down here, this one has an n squared, right? But we talked about this in class. There's no other n's involved. So this one we can actually just get n by itself. So we're going to add 3 to both sides, and we end up with 4n squared is equal to, when we add 349 plus 3, we get 352. Okay, we're then getting rid of the 4, so let's divide by 4. We get n squared is equal to 88. And then we square root both sides. So to undo the squared, we just square root. And remember, when you do that, you need to bring that plus or minus in because that's representing both solutions there. So plus or minus the square root of 88. And then our final answer, we would just break down the 88. So 88 would be like 8 times 11. Break down the 8, 4 and 2. And 2 and 2. So it looks like we've got a group of 2's there. So remember what we practiced on the last assignment, right? The 2's come out front of our radical. And 2 times 11, those are the leftover ones, get to go back inside. 2 times 11 is 22. All right, 13, very similar. Again, we're solving this one, so we're solving for our x-intercepts or when y is 0. So we're going to put a 0 there. And it's tempting to want to like do something with this squared initially, but remember this is just like the last one, except we've got a bigger x piece. So just like we got n by itself, we're going to go ahead and get the x piece by itself so that we can square root both sides. So we are going to start by adding 4 to both sides. So we end up with 4 is equal to -2. X minus 4 squared, and we got rid of that. Then we go ahead and get rid of this -2 in the front. So -2 here gives us -2 is equal to x minus 4 squared. Now again, we can't take anything out of that parenthesis until we get rid of that squared. So we're going to square root both sides to get rid of that. And that just leaves us with the x minus 4 on that side. On the left side, remember if there's a negative in there, we're going to bring it out as an I. And we're going to have the square root of 2, and then don't forget your plus or minus sign there. Okay. Lastly, solving for x, we just want to add the 4 over to the left side. So we're going to add 4 over here. And that leaves, we've solved for x. On this right side, we've got that would equal to 4 plus or minus I times the square root of 2. It's a little crooked. All right, solving with square roots. So if any time you just have one x piece or n piece or variable piece, then you can just solve for that piece. All right, lastly, let's go back to our quadratic formula. It's been a while since we saw this thing. State the quadratic formula that can be used to solve a quadratic of the form ax squared plus bx plus c. Now remember, the formula worked for any quadratic equation because we just used the coefficients a, b, and c in our formula. So this is our Pop Goes the Weasel song, right? X is equal to, we did the opposite of the b value. So whatever the b value is, negative means opposite, plus or minus the square root of b squared minus 4ac all over 2a. You're welcome. Okay, there's our coefficients. So when we jump down here and use the quadratic formula, we're going to practice all of that. Notice also that it's equal to 0, so that step still holds true. So on 15, again, we would set it equal to 0, where 15 is already equal to 0, so we're ready to identify our A, B, and C. In this case, right, if we don't see anything written there, we know that A is equal to 1, B is equal to 3, and C is equal to 9. Don't get confused by those B's in there, right? Those are like our X variables. Then we just set this up in our formula. So we do the opposite of B. So if B is a positive 3, we're going to do negative 3 plus or minus the square root of 3 squared minus, in our formula, we got 4 times A is 1, times C is 9, all over 2 times the A value. From there, we just had to simplify, right? And that represented our solutions. So from here, again, we're going to say, well, that negative 3 will stay out front, plus or minus. Then we need to simplify the radical part, and this is all over 2 times 1, or just 2. So the radical part, again, we can just plug that whole thing into a calculator. That would be 3 squared, which is 9, right? Minus 4 times 1 times 9, so minus 36. That's going to give me a negative 27 in here. Okay. For our final answer, we want to simplify the radical. So notice that negative is going to come right out here, right, and become an I. And we can break down 27, which would be like 9 and 3. 3 and 3. So in this case, we're going to have negative 3 still in front, plus or minus. That 3 gets to come out front of the radical. So not in front of everything. It's not coming clear out here. Just sitting out front of the radical with that I. And then we've got the square root of what's left, so that 3 didn't have a group. Lots of 3's there. All over 2. Okay. Now, lastly, we do want to make sure if there's a greatest common factor that's common to all 3 coefficients, then we could simplify that. In this case, there's not. So we've actually simplified as far as we can go, and that would be our final solution there. Okay. Again, let's look at one with a value on the other side. So let's look at 18. On 18, notice that this one is equal to 14. So we've got this term, right? We've got 12n, and then we've got 14 on this side. So we want to move the 14. So let's subtract that 14 over here. Now, I wrote it kind of weirdly in the middle. But again, I'm going to write it in standard form. So I've got 6n squared. I've still got that 12n, and then I'm just moving the 14 over so that they're all on the same side. From there, again, we look for a greatest common factor. Now, you can identify your A, B, and C if you want to first, or if you want to divide out a greatest common factor, it just makes your values smaller. So, for example, these are all divisible by, not 6. 14 is not divisible by 6, but it looks like they're all divisible by 2. So let's divide everything by 2. So we're going to have 3n squared plus 6n minus 7 is equal to 0. Okay, then from there I can use this quadratic formula. So A is equal to 3, B is equal to 6, C is equal to negative 7. Okay, so let's plug it into the formula. Opposite of B, so that's a positive 6. I'm going to do negative 6 plus or minus the square root of B squared minus 4 times A times C all over 2 times A, which is 3. And then we simplify. So again, we've got this negative 6 out front, plus or minus. We got our square root piece there, all over 2 times 3, which is 6. Now it's really tempting for a lot of us, right? We see these two numbers here and we want to simplify. But remember, in order to simplify, we have to have it common here and this coefficient, which we haven't simplified yet, and this one. So it has to be common to all 3 pieces in order to simplify. So let's go ahead and figure out what's inside the radical. We got 6 squared, right, minus 4 times 3 times negative 7. So it should give us 120 there. Okay, so we're going to go ahead and break that down. So that would be like 12 and 10. 2 and 5, 3 and 4. If we break down 4, we get 2 and 2, so we've pulled that down. Looks like there's a group of 2's there. So that 2 gets to come again right out front of the radical. So I'm going to put this over here. I'm running out of room. -6 plus or minus. We know that 2 is coming out front. And then it looks like on the inside we're going to have a 5 times this 2, so that 10, times this 3, which is 30. So on the inside of here we've got 30 that couldn't break down, all over 6. Now again, we're almost done, but we do want to look at these 3 coefficients. Is there anything that divides into -6, 2, and +6? Well, all of those are divisible by 2, right? So if we divide -6 by 2, that's like -3. 2 divided by 2 is just 1, and 6 divided by 2 is a +3. So our final answer would look like -3 plus or minus. You can write the 1 if you want, because it's a 1, we don't need to, all over 3. Okay, and that's as tricky as those can get. You're really just simplifying, until you can't any further. All right, last section says solve each equation using the method of your choice. So again, you're just going to walk through those steps. You can factor or use the quadratic formula. So let's look at one of these. Number 19. Again, the first thing we want to do on all of these is set it equal to 0. So I have an 80n here, so I want to subtract that over to this side. Okay, so I'm going to have 8n squared minus 80n. Again, that's not a like term to any of the others, so it's just going to sit there in the middle. And then I didn't leave anything on the right side. Next thing we do, right, is we look for a GCF, or greatest common factor, something that divides out of everything. So notice that these ones are all divisible by 8. Okay. And if we go ahead and divide those by 8, then we end up with n squared minus 10n plus 168 divided by 8 is 21 is equal to 0. Okay, then at this point you can either factor if it's factorable or use the quadratic formula. So you can decide which one you want to use. I'm going to see if it's factorable first, because that's the fastest way to go. Especially because there's no number out front where we'd have to use that bottoms-up method or factor by grouping. So we look at 21 and we decide if there are factors. So either 1 and 21 or 3 and 7. Those factors need to have the same sign and they need to add or combine to -10. So if these are both negative, the -3, -7, right, those would get us to 10. So we're going to have n minus 3. N minus 7 is equal to 0. And then again, like we solved earlier with this, we just say, well, what makes this piece equal 0? Well, that would be +3. And what makes this piece equal 0 would be a +7. Okay. Again, you can use the quadratic formula on those. Also, quadratic formula will work on any of these. So you can use it at any time. Just remember to make sure it's equal to 0 before you identify your A, B, and C values.